Okay, let's finish up this Mesa DC-5. People think that I hate Mesas, like I just arbitrarily chose a company to hate, or that Randall owes me money or whatever. No, I find them really badly designed and really poorly built, and it really takes advantage of a lot of musicians. I don't find that an admirable combination of factors. Anyway, on this one, this 220 ohm had burned the pads down here, and someone had tempted in with that red wire that you saw, trying to reuse one of the burnt solder pads on the board. That didn't work. This is a 5 watt 220 ohm resistor, and it is jumpered between this diode and the other leg of this 1 watt carbon comp, which is a 1K, and that is equivalently the same as where it used to be. The silicone is not lovely, but it takes a lot of the stress off this, and this does not have any, it won't cut out, and it shouldn't come disconnected, and it clears the top of the chassis. So we're calling that fixed. Let me show you some other considerations in this particular model, this DC-5. These 470 ohm carbon composite screen grid resistors often fail in Mesas. Sometimes they just develop an internal crack and they don't work anymore. Sometimes they like to burn, and when they burn, because they're mounted right up against this board, they burn the board. And because the traces are very small and the pads are microscopic on the board, they damage the board a lot. So I'm going to change these, and let me show you a good indication of that. These should be 470 ohms, and even within the tolerance of a carbon composite, this one measures 409.4. This one measures 390.4. So they're well off from 470, and they're a bad material, and these will fail at some point in use, and when they fail, they will cause, most likely, fairly extensive damage to the board. So I'm going to change them out preemptively because I like my clients. And if I were half as evil and cynical as people seem to think I am about Mesas, I'd leave these in here and let them burn, and then I'd get another job in the future with a whole new labor fee. But I'm just going to do these while I have the amp open and save the client some money and potentially save his board in the process. Let me change those out, then I'll show you the other big thing about these amps. So now I have two 470 ohm 3 watt wire wound resistors with the leads crimped so that there's a lot of air between the board and the body of the resistor. Should these get warm, the board won't get warm, both because of the air here and because that heat will dissipate through the longer leads. I can't do anything about the tiny little traces run parallel to each other with almost no gaps on the board, and I can't do anything about this coating that they use, conformal coating, which gets sticky and tacky and absorbs yuck from the atmosphere, which eventually becomes conductive and causes arcs in these. But I can at least take out these common modes of failure. Let's look at one other thing that often fails in these. The other big issue in these amps, DC-5 and other Mesas, are they use a lot of 47 nanofarad 400 volt caps, these orange drops. And there's nothing wrong with these caps, except they are underrated for voltage. So right now the amp's in play, it's out of standby, it's got its full current draw, well, it's full idle current draw, and the bias supply is negative 47 with 116 volts out of the wall. So that'll be a little bit higher, closer to negative 50 as wall voltage goes up. And the B plus in this amp, well, let's measure the B plus at pin 1, which is the other side of these caps. 267 plus 47. So we're about 314 volts there on a 400 volt cap. You'd think that's great, right? So 314 volts across the cap in total, 400 volts, no issue. If I put the amp in standby and see what the unloaded B plus of the amp is, the unloaded B plus is 452. 452 volts unloaded B plus. And then we still have that negative 47, which is probably going to go a little bit higher, negative 47.8. So 450, negative 47. So we have essentially 500 volts present when the amp's powered on but in standby. Now, if someone forgets to have it in standby when they power it on, because this is a solid state rectified amp and the B plus is so high and those caps are rated so low, then you're going to have 500 volts across this capacitor until the output tubes and the preamp tubes, primarily the output tubes, start drawing current, which brings it back down to its normal state. If this phase inverter tube were to die and not conduct, then you could be right approaching 400 volts. If you have a bad output tube, so that the output tube is not drawing any current, or both of them aren't drawing any current, even if you use standby correctly, these capacitors can have more than 400 volts across them, from the positive at pin 1s and pins 1 and 6, and from the bias, which is negative 47 to negative 50. So these commonly fail across the Mesa model range, and I end up changing them a lot. The first symptom you'll have that you'll notice is that you'll hear a buzz in the output, even if the master volume is at 0, because the master volume is before the phase inverter in these amps. So you will hear a buzz start. There is no buzz in the output. These have not begun to fail yet. But as they begin to fail beyond just a little bit, which is annoying, they actually throw the bias off. So if this is supposed to be negative 47, negative 50, and this leaks 3 volts positive, then you're at negative 44, negative 47. It goes down by whatever is leaking. If this leaks 10 volts, 20 volts, 30 volts, your bias can go crazy, crazy hot. They draw more current. The tubes can actually fail. The bias resistors can burn. The board can burn. And this happens quite a bit in Mesas. I'm not just making stuff up because I want to be the guy who hates Mesas. That's a very reductionist view of this. I have measured a lot of fundamental design and layout flaws in these amps. And the DC-5 series has fewer flaws than many of their other models, but it has serious flaws. And someone said, "Oh, you're criticizing an amp that's lasted 27 years." The owner got lucky. Most of these don't last 27 years. And a 27-year-old Fender from the 60s, so you have to go back to the 80s to view that, was in a lot better shape because Fender did not make such colossal mistakes. They also weren't designing PCBs with no knowledge of how to design a PCB for longevity. So I digress. Anyway, for now, I'm not going to change these out because to physically access them is very difficult on this board. There are these large components here, so I can't get it from this angle. It's hard to get it from this angle. There's components mounted here. The best way to change these out on this model is to actually remove the entire PCB, lift it up, do it from the bottom. But again, like I mentioned in the previous video on this amp, to do that requires disconnecting and then reconnecting several hundred connections, and it would just cost an arm and a leg for the client. So that is a repair which will be kicked on down the road only if it's necessary in the future. Sadly, in my experience, not in my opinion, not in my whatever, in my experience, this happens a lot in a lot of Mesas, and I don't know why they just don't use 600 or 130 volt caps like most manufacturers do. They cost a few cents more. They're about the same size. It's usually a no-brainer. And that joke just writes itself, so I'm going to stop right there. Anyway, I've got the new knob on and the new sliders, and this amp's ready to be put back together. Let's see how it sounds. Well, I thought I was going to be done with this amp tonight. Put it all back together, and the reverb tank doesn't work, and you can see the springs literally falling out of it, so I've got to order a new tank for this. And their tank is a different ground scheme than most, so I had to slightly modify the ground scheme on this test tank. But the reverb is working. But the issue now is that the clean channel hums and the dirty channel does not. So I'm going to move the mic closer to the amp. And that was the hum from the dirty channel. And it's probably one of the two 47 nanofarad 400 volt caps in the clean channel. But it could be a bad cathode capacitor. It could be something funky in the LDR switching. I don't think so. I think it's more likely leaking DC that I'm hearing. The culprit on the left, 400 volts. The new one, 630 volts. The one on the left, Illinois capacitor. The one on the right, Panasonic. Okay, 2 leaky caps later, and some bad solder connections on these badly shielded runs. The amp is sounding a lot better. The hum is down to normal levels for a DC-5, which is still not a quiet circuit, but in the settings people use, it's on the verge of acceptable. I need to get a new volume pot for the clean channel though. There's a switch volume pot that's easy to change out, because this one is just really fragile and janky, and it's a tiny little thing, and if I turn the knob too hard in either direction, the pot moves, and it's as tight as it goes. It's just a flimsy pot. But anyway, here's the clean. Pull boost. And overdrive. All right, there are things I would like to change about this, but there's only so much windmill tilting I can do right now. I don't want to break the guy's budget. It's probably better than it's been since it was new. One more volume pot changed out just because that's going to fail in a tragically predictable way. It's just not a very good quality pot. None of them are, but that switched one is really abominable. And I think I've got a suitable replacement already here. If not, I can get one on Tuesday. So almost done.